and a little bit on naming triangles and stuff like that. So you have to be able to name triangles properly to even know what these questions are asking you. So the very first thing we're going to do is we're going to look at this triangle. This triangle ABC is what we would call it. You'll normally see triangles, you'll sometimes see triangles written like this, so it'll be a little triangle, and then they'll say A, B, C. That's shorthand for triangle ABC. So it's just math talk. There's also a little bit of math talk on how they discuss the triangle. So how they discuss where A goes, how they discuss where B goes, and how they discuss where C goes. So that's down here. It says an angle in any triangle can be named using one letter called a vertex, where two lines meet and create an angle. Or it could be named by using three letters where the vertex of the angle must be in the middle. We commonly, if we were just talking about it, I would call this one angle A, because it's in the corner where the big A is. I would call this one angle B, and I would call this one angle C. So if we're talking about it, that's how I would refer to these things. When they write it mathematically, it looks like this thing right here. That says angle A in math. So on a question on a test, they might say find, and then they'll use those symbols. That means angle A. Another way that they can do it is they can write out three things. So angle A is the exact same thing as this right here. That's angle BAC. The middle letter is the angle that they're always referring to. So angle A. Whatever letter's in the middle, that's the angle they're talking about. Which means they could actually say this a different way. They could flip where the C and the B are, and they could call it angle CAB, angle canal. That's the same thing as well. So that's three different ways of saying angle A, but using math terms. All three will show up on tests. All three will show up in practice booklets. All three will show up on your assignments. So if we were to do this for angle B, you could write it as angle B, or you could write it as angle ABC. Now what's another way I could do this one? Angle CBA. Collective bargaining agreement. Okay, try to fill out angle C. So what are two different ways you could write angle C? So you could write it angle ACB, or you could write it angle BCA. As long as C's in the middle, you know that's what they're referring to. Now, more commonly than not, they'll do it the alphabetical way. So, for instance, they would choose ABC over CBA because of alphabetical reasons. But either one is correct. All right. If that wasn't confusing enough, then they have different ways of labeling your sides. So that's how you label your angles. You label your sides in two different ways. So the first way is to describe it as from corner to corner. So I would call this side AB because it goes from A to B. And I write it like that. Side AB. This bottom one would be side BC. And this one would be side AC. So you can describe it as going from corner to corner. That's one way. Second way that they name it, and it's the way that's more commonly done, in my opinion, is what they do is they do the opposite angle. So for instance, angle side AB. It's connected to angle C. So what they do is they say angle C created side little c. And they do a lowercase letter for side lengths. So we'll do a couple of these. That means angle A would connect down here, and that would be side little a. Which means this long one here would be side little b. The side opposite the angle, you just call it the lowercase letter of that angle. That's the most common way, in my opinion. With the little a's, little c's, the little p's, little b's, all the little letters, that's more common. So if you were to fill out this thing, side AC is little b, and side BC is little a. Before we get into trig and we start doing kind of calculating of angles and stuff, it's good to understand how triangles work. So triangles work based on ratios. That's how it all works. An angle is always going to create a certain side length. So for instance, if I had an angle of 90, I'm going to have a bigger side length than if I had an angle of 2, which only makes sense because when you're building triangles, that angle that you've chosen to create something at, that's what's creating this side length opposite. So that's big C, this would be little c. And depending on that angle, depends on how long that line would be. Rule of thumb, bigger angles make bigger side lengths. Smaller angles make smaller lengths. So in this question here, it says if angle BAC, so where would angle BAC be on my triangle? And at the very top would be right here. That's angle BAC. Is 53 degrees. So 53 degrees. Correctly label the triangle above with these side lengths. So, you've got 3 side lengths, 5, 12, and 13. The biggest side will go with the biggest angle. On this triangle, do we know all the angles? We know 53. What's this one here? 90. We know that this one's 90. Do we know what this third one is? We don't, right? It's a trick to figure out the third one. Anytime you know 2 angles, you know the third. Because all angles have to add up to be 180. So if you ever want to find the third angle, you go 180 minus the other 2. And that'll tell you your third angle. So in this case, it is 37. All angles in a triangle add up to be 180. Now that we know all of our angles, we can figure out which side lengths are which. Because the biggest angle gets the biggest side length. So which one's our biggest angle? 90. So the side across from 90, this one over here, should get the biggest side. So it must be 13. Because 13 was the biggest side that we were given down here. Where would side length 12 go? Across from the 53, well, how would we describe that side? What's a way we can call it? Side BC. Right, so 53 goes across to here. That's side length 12. That means the last one, kind of by elimination, has to be 5. But notice, the biggest angle is the biggest side length. The smallest angle, the smallest side length. It'll always work that way, I promise. Who remembers Pythagorean Theorem? Hey, good, because we've been doing it kind of throughout the year. So, we're going to do a little bit of review on Pythagorean Theorem. Pythagorean Theorem is only useful with a 90-degree triangle. Luckily for you, everything's a 90-degree triangle in this class. So Pythagorean Theorem will work for every triangle you have that has a 90-degree angle. It's useful when you have two sides and you want to find a third. It's the only time you can use it. So anytime you have a right angle triangle, and anytime you know two sides and you want to know the third, you use Pythagorean Theorem. To use Pythagorean Theorem properly, we need to know how to label our triangle. We need to know what A is, we need to know what B is, and we need to know what C is. C is the only one that's important. Okay? So if you can figure out which one C is, A and B really don't matter. Who remembers what C is? Which one is it, Shane?
The question mark.
It is the question mark. And Nick used a good word. What was it, Nick? It's the hypotenuse. So C is the hypotenuse. Right there. It says it in the question somewhere. Yeah, there it is. That's nice, right? Then I can spell it. The hypotenuse is the longest side. The longest side is always across from your 90. So this one here is little c. A and B don't matter. I can call this one A, and I can call this one B, or I can call it opposite of each other and it wouldn't make a difference. A and B don't matter as long as you have C labeled correctly. Now, to use Pythagorean Theorem, we take our side lengths and we put it into the equation. You'll always be given this equation. You won't have to memorize it. Okay? So, we put 3 in for A. So it becomes 3 squared. We put 4 in for B. Plus 4 squared. Equals, do we know what C is? No, so we leave it as C. 3 squared is 9, plus 4 squared is 16, plus 25 equals C squared. That's not your answer. What do you have to do last? You got to square root it. And you have to square root both sides. You didn't want to know what C squared was, you wanted to know what C was. So 5 would be your missing side length in this question. Now, a little side note, there's no slide on it, I took the slides out on it. This right here, see how all of our sides, 3, 4, 5, they're all whole numbers? That's pretty rare. It's pretty rare that you get 3 whole numbers as your side lengths. Usually you get 1 or 2 that are decimals. When you get 3 perfect numbers like that, it's called a Pythagorean triple. So just kind of an odd thing to make note of. You really don't need to know much about it, but if you see Pythagorean triples with these whole numbers, just know that they're pretty rare and it's kind of a cool thing. They rarely happen. Alright. Do this first triangle on your own. So try to calculate it on your own. Alright, if we look at this first one, we had to properly label our triangle. So your first step was knowing that what you're looking for is little c. It's your hypotenuse. Meaning that this one's A and this one's B. And if you flip that, so if you call them the other way around, that's fine. That's okay. You then have to put it into Pythagorean Theorem. So 3 squared plus 7 squared equals C squared. Let's go up there. Anyways, you do the 9 plus 49, right? Because that's what these things squared are. That's where I got 58. And then you square root 58. That's always your last step. So you got 7.62 is your missing sign. We're going to do the next one together because it's a little bit different. First step to every question is going to be labeling your triangle properly. If you want to use Pythagorean Theorem, you need to label them properly using A, B, and C. Which one would be C in this case? 12. The longest side is always C for Pythagorean Theorem. A and B don't matter. So I'm going to call this one A. I'm going to call that one B. Now, I believe last year, you guys got taught a second formula for Pythagorean Theorem. It was B squared equals C squared minus A squared, I think, right? So I don't like to do that. Because I think it diminishes your guys' ability to do that. I think you guys are smart enough people that you can set this up, use the exact same formula that you've always had, so A squared plus B squared equals C squared, and still answer the question properly. So that's what we're going to practice. We're going to put this thing into Pythagorean Theorem. So A squared, 7 squared, plus B squared equals C squared, 12. I'm then going to convert those numbers. So 7 squared is 49. B squared is still B squared. And 12 squared turns into 144. Now, if I want to figure out what B is, I need to get B all by itself. So I need to move everything that's next to the B away from the B. So how can I move this plus 49 to the other side? You subtract it. Yeah, you do the opposite. So instead of plus 49, I'm minus 49 from both sides. Minus 49, both sides. That'll leave me with B squared equals 95. So you guys can do that. That's not difficult. You don't need a second formula. You just need the one Pythagorean theorem, and you guys can solve things. What's my last step have to be? Square root. So you square root both sides. And what's B equal to? What is it? Nice. 9.75. So your missing sign length is 9.75. I won't give you a second formula. I think you guys are all capable of that. That's not asking a lot. Go ahead, do this third triangle on your own. I'll put my answer on the board. Okay. So if you remember the other way you did it in grade 9, that's fine. Like, that's still gonna work. So if you're like, oh yeah, I've got that memorized, yeah, that's fine, work with it. Just know that I'm never gonna provide it for you. If you want to do it this way, that's good too. If you want to do it the way you already know it, that's fine. As long as you're getting the right answer, you're good. I'm just not going to give you that formula. Alright, we set it up. We labeled our triangle ABC. C was my hypotenuse, so I nailed it. I then put in my numbers. I got 9 plus B squared equals 225, minus 9 from both sides. Square root both sides, 14.7. How many people got that? How many people are like, we did this in grade 9, that's easy. Yeah, same kind of stuff. Okay. Luckily for us, we don't spend a lot of time on Pythagorus. So we're going to keep going into 3.0.